The intensity of light in water is decreased as you go deeper. The intensity at several depths is given in the table. We're given the depth in meters and the intensity as a percentage. So at the water level, we get 100% of the light intensity, whereas if we go a meter deep, we only get about 25% of the intensity. Find an equation for a model of these data. All right, as before, let's create a model. Let's call D the depth, and let's call I of D the intensity. All right, so let's look at the data. Let's edit our points. All right, so let me clear out the old stuff. Let's look at some new stuff. All right, so 0, 1, 2, 3, 4, and 5. 100%, 25%, 6%, 1.5%, 0.4%, 0.1%. All right, let's set up a window. So I'm going to go from, say, -1 to 6 and scale by ones. I'm putting the -1 there just so I can just kind of move the graph over a little bit. I can see more of the data point at 0, 100. All right, and for my y minimum, let's go to, say, -10, and my y maximum, 110. And I'll use a scale of 10s there. All right, my stat plot is on still. Y equals screen. Let's clear out that old function and hit the graph key. All right, and I see the data points, and I see how it's decreasing and then flattens out. So again, an exponential function makes sense. So let's use an exponential. Exponential model, so I'll say that I of D is equal to A times B to the D. Choose a couple points. I'm going to use 0, 100. And I'm going to pick a point further away. I'm going to use 4.4. Now, since I'm using 0, 100, that makes life a little bit easier. Since I have that point 0 something, I know then that A is equal to 100. So I have I of D is equal to 100 times B to the D. Now I'll use the other point. 4.4 tells me that 0.4 is equal to 100 times B to the 4th power. So 0.4, let's divide through by the 100. And so that would be 0.004 is equal to B to the 4th. And that's a power equation, so I'll raise both sides to the 1/4 power. And so 0.004 raised to the 1/4 power is approximately 0.25. So this tells me that B is approximately 0.25. So putting that together, I would have that I of D is equal to 100 by 0.25 to the D power. Again, let me check that on the calculator. Let's graph it as 100 by 0.25 to the x. Graph. And this looks like it fits the curve very well. In fact, it seems to go right over the points. So I'm very happy with this function, this model. Part B. Estimate the intensity of the light at a depth of 6 meters. So, 6 meters, that tells me that D is equal to 6. I of 6 would be equal to 100 by 0.25 to the 6th power. On the calculator, that gives me 0.024. So, at a depth of 6 meters, only about 0.024% of the light intensity remains. Give a reasonable domain and range for this model. Domain. Now, usually we say go a little bit left and a little bit right of the data points. Well, our first data point is at a depth of 0. Negative depth doesn't really make sense here. So for the domain, I would stick at 0 on the left. Now on the right, I would go to maybe 6. Not much further. Now for the range, we already found that we have 0.024 as a minimum. I shouldn't say as a minimum, but as the value when the depth is 6 meters. And we know the maximum intensity of the light is 100%. So for I of D, I would put the range at 0.024 to 100.